Cannot. But I don't think people see. Maybe for your junior, like your junior will see that. So impulsive force. Okay, so now based on your answer, what will happen to the impulsive force act on the man as the man sink deeper into safety cushion? Explain your answer. Sink deeper means it will shoot. So sink deeper actually means, by the way, what is this timer? What is the name of this timer? Please recall back. Call impact time. What is impact time? Impact time actually is the time from contacting, from hitting until stop. So for example, this is cement. The egg drops, directly stop. Directly stop means the impact time is small, maybe 0.001 second. Then this is cushion. So the egg sink and elastic. So means that the egg will like vibrate a bit. We can't see that because actually also it's quite fast. Sink and increase. Sink, increase. So the time will be longer. So time maybe 0.1 second to stop. So we say this is longer time. This is shorter time. So sink deeper. So the question says sink deeper. Let's say sink deeper, come back, sink, come back, sink, come back. So it will take longer time like it. So we will say what happened? Impact I sink increases. Okay. So I'll explain your answer is impact time increases. So the impulsive force decreases. Like that. So impulsive force, impact time. When something hit. Okay. And then but this one is called impulse. Okay, like impulsive force just now is F equals to mv minus mu over t. So we say it's the rate of change of movement. So a impulse is Ft equals to mv minus mu. The t we move up. So impulse. This is impulse. This is impulsive force. So impulse can be F times T or can be mv minus mu. So impulse is just the change of momentum. So this one, impulsive force, when something hit, contact, full surface contact. Okay. Then Ft is impulse. Impulse is normally when we play ball, we apply the ball with longer force. A softball player hit and exerts 70 Newton of force on the ball with the mass 0.3 kg, which is moving at velocity this. Contact time of the ball with the bat is 0.2 seconds. See. This time, we call it as contact time. You may say, hey, teacher, I think the same thing, like impact and contact the same thing. Yeah. If you check dictionary, it's almost the same thing, but I would want to use impact time because it's like very fast, it impact. But this one is we want to apply our force with the contact time. Okay, so now for example, so this one called follow through. Impulse always apply in follows through motion of any ball. Follows through. Follow through slow motion. This one, wherever golf ball, wherever ball. Okay, now, so why this man he hit the ball from here to here? Why don't he just here to here? Why he put A, but not just hit the ball in just B? Because if he hit the ball starts from here, A means the contact time to apply force is longer or shorter? Is longer or shorter? You swing it in longer time, right? Swing in longer time. So contact time is longer. If you swing short, so this contact time is shorter lah. Longer. So now our impulse now how? Let's say the force is 70 Newton. Longer time, let's say is 1 second. Then you will get 70 Newton second. So this one, let's say shorter time, 0.1 second. Then you will get 7 Newton second. Okay, so can you see impulse shorter? That's why I would like to say this is contact time. The hit one is impact time. Impact means the hit. This one is the time contact to apply the force. Okay, so be careful about the impulse and impulsive force. Impact time, contact time. Okay, so the impact time is Ft equals to mv minus mu lah. So impulse would be, since we got what? Impulse. We got 470 Newton, mass 0.3 kg, velocity 60 kilometer per hour. Be careful, since this is not SI unit, most of the time you need to change it lah. So 60 kilometer per hour change to meter per second. Hello? Yeah, I am.
Trên gia phòng đánh tạm trả Aridas là second personal đánh tạm lại số
Personal.
and these second like your turn and these like third can see whether you can take like second like
No. No. No need.
For the last case that's
No. Okay. Take it back. Okay, so you all know how to change, right? You all know how to change, right? Okay, then the contact time is 0.2 second. Yeah. Scammer, yeah. A bank call. Do you need a personal loan? I say no need. It's okay lah. Oh, by the way, if you get scammer call, like they silence, you also silence because now they can record your voice. use AI make scam. So better don't have any sound. Okay, so now FT equals MV minus MT. So actually you can use FT or MV minus MU lah. Softball. And better don't use this because they don't really give you. So we say impulse equals to FT lah. So it's 70 times 0.2. So 724, you will get the answer 14 lah. Then just now I just asked you, I just sent a message. Where's the message? Hey, yeah, may the force be with you. Here. After you do everything, please check that all of your calculation with final answer. If got 3 decimal, please put at least 3 with proper unit. So you just use 1 minute check every calculation. Okay. So this one no unit wrong lah. Like what's the unit? It should be Newton second, okay, or kilogram meter per second, okay. Should be Newton second or kilogram meter per second. Both. So yeah, impulse got 2 units. Okay, so after the ball is hit, the ball is bounced to opposite direction. Calculate the rebound velocity of the ball in international unit. SI unit means, yeah. So just now we change already lah. Congratulations. Okay, after the ball is hit, the ball is bounced in opposite direction. Calculate the rebound. Okay, so now means the ball go here 60 kilometer per hour means 16.667 meter per second. So let's say we say this is positive lah. So we say U lah. Then it rebounds with V equals to don't know. Then we can use back. We can use back we can use back here. We can use back this. Ft equals to mv minus mu. Ft equals to mv minus mu. For me, I will factorize first because I don't like to write mass for 2 times. So impulse we get already 14. Mass 0. Just now we write in 4, please write in 4, please. Last round already, write in 4, please. 0.3. Then V minus U is 16.667. Then just solve it. And then you be careful lah. Actually, this is number 2. This is number 1. So this is C. C number 2, number 1. So I would say that so the answer will be 14除0.3加16.667. So V will be 63.333 meter per second. Okay. So when you have no idea what's the formula, you look at this. This is number 2, means it's related to number 1 and related to C. So normally B and C could be different concept. Like this, B is impulse force. C is impulse. They're related a bit, but not really the same concept lah. So this is what we learned in exam. Okay, so now next. So okay, impulse and impulsive force very clear here. It's popular question, by the way. Okay, diagram 3 shows 100 grams of cold water at temperature of 8 degrees Celsius being poured into the glass containing 44 grams of hot water at temperature 70 degrees Celsius. Okay, this one I encourage you all draw a box like this. Why? Sorry. Wait. Mine must be the teacher. If it rebound, why the velocity not negative like momentum? Yeah. V. Yeah. Why? Am I doing something wrong? 19.3. Yeah. Yeah. 不是，它是减 positive 减呢？它应该是减呢。Yeah, lor. Why? Last time what I do got repulsed one. Never mind. Just got magnitude is enough lah. Actually, for here it should be negative B, but here don't have. So it's okay lah. For 5, magnitude is enough. Okay, so now this one. Next here got 2. One got water, one got water. But what's the difference between these two water? I would put the hotter one. I'll follow the number line. The hotter one is here. Hotter one 70 degrees. This one is 8 degrees. I encourage you all to do this box easier to calculate. So now the 71 is mass equals to 44 gram. This is mass equals to 100 gram. So should we change to SI unit? Not necessary, but if you want to change, it's okay. Why not necessary? Because normally they will ask what's the final. Normally they will ask what's the final temperature. Okay, so now this one you all know lah from chemistry, learn a lot already. Heat will transfer from higher rate from higher temperature region to a lower temperature region. It's like bonus for you. Alright, so now based on diagram 3, calculate the final temperature after a few minutes until there's no change in temperature, means they reach thermal equilibrium. Okay, so now since both are water, be careful about here. Why? Because we are going to use finally the heat from, let's say this is A, this is B. The heat from A will equals to the heat from B. Means what? Means QA will equals to QB. What formula related to the change of temperature? I believe you know lah, is Q equals to MC theta lah. MC theta. I prefer you all write delta theta. Why? So it's Q equals to MC delta theta. MC delta theta. Why? Because delta theta actually means the big temperature minus the small temperature. the difference. Delta means the difference. Difference means big number of temperature minus small number of temperature. Okay, then both of them are water. So the C is the same. We can cancel lah. So then the mass for A is 100 gram. For B is 44 gram. That's why I say no need change to kg because both side gram will be cancelled. So the ratio is the same. But if you want to change, also no harm. If you want to play safe, you say, everything I change SI unit can. When I was young also, I feel, so many things, so I change all to SI unit can. Okay, so now this data is, this one will be in between 8 and 70. So for A, the changes will be theta minus 8. Then for B will be 70 minus theta. You may ask, teacher, why not we just use 8 minus theta and 80 minus theta? If we do this, you will find out both sides unknown will be cancelled. So don't do that. So do not do this. Because both sides unknown will be cancelled, and what we find? We find nothing. So now we use the big one. This comparing here, this is big temperature, this is small temperature. Comparing here, this is big temperature, this is small temperature. That's why theta minus 8, 70 minus theta. And I encourage you to put delta here because it's the difference. You need a minus. Okay, then you will get 100 theta minus 800 equals to 44乘80。44乘80，答案是3520减掉44 theta。Then we will get, we move lah. 800 theta. Oh, okay. So we will get 144 theta equals to 3520. This one we move here plus 800. 加800. Then theta equals to 214. 30 degrees Celsius Celsius 70不是80 70不是80。C. I'm testing you. No, I really make mistake. Here. It's 70, not 80. Yeah, thanks for Hanlun for reminding. Yeah. And I everything wrong. Everything wrong. Then do yourself. Okay, so physics part actually until here, the rest is maths. So you get 100 theta minus 800 equals to 44乘70 so 3080减掉44 theta. Then answer. Yeah, lor, exam no mark already. Hiya, no mark already. Hiya. So now get the idea. I've got two things. Draw the box. Small temperature here, high temperature here, temperature in between. Okay, good. Teacher, what is the function of relay switch? To use small voltage circuit, switch on high voltage circuit. For example, your car. Okay. Relay switch. Okay, I can ask. Relay switch. Where's my relay? Here, relay. Okay, something like this. Okay, relay means here got two circuit. So we use First circuit is small voltage circuit. Small voltage circuit. This is big voltage circuit. We use small voltage circuit to switch on big voltage circuit. So see, we on first voltage circuit, then it will relate the current will start to flow in second circuit. Why? Why cannot directly on big voltage circuit? To avoid electric shock. And so that's why actually when we start our car, we press button or we just use the key. We switch on the small voltage circuit, then we are not contacting to the voltage, so we won't get electric shock. Especially this one, we use this in factory. The machine, they use maybe 10,000 volts that 1,000 volts, the heavy duty factory. Imagine you touch there, directly we get electric shock and bye-bye. Okay, so we use small voltage circuit to switch on large voltage circuit. And also, for transistor, must also have two circuit, because transistor, we switch on transistor, black transistor, switch on the relay switch for the motor. Because transistor only can accept like 10 microampere of voltage. But this motor, this fan, our let's say our handphone, the current 3 ampere actually is quite large, So 3 and 0, this one should be 0.00001 ampere. So actually how many times difference? 1, 2, 3, 4, 5. 5 means 20, 百, 千, 万. Actually it's 10,000 times bigger. These two, the difference is not, it's not 1, 2, 3, it's 10,000 times difference. So we use small circuit voltage, small voltage circuit to switch on large voltage circuit. So that's the use of relay switch. See Jesus, if we directly touch, we see Jesus already. So relay switch is like that. Yeah, also my neighbor said, last time I was checking my car battery. He said, don't touch, You will never want to feel the 12 volts battery direct current. He said, I'll never want to experience that again. So actually we start the car, we are not touching the battery. We are using small voltage circuit to on the large voltage circuit. Okay, what is the physics concept thermal equilibrium? What's the reason for your 2C? Because finally they reach same final temperature. Same final temperature and no net heat flow. Same temperature, they reach same temperature. I always say same final temperature. For me, I like to get final. Same temperature is enough already, actually. Okay, give one assumption need to be made in order to apply the physics concept mentioned. No heat loss to surrounding, same as your chemistry. Okay, everything about heat no heat loss to surrounding. But in our real world, cannot sure loss a big one. Okay, so now this one. Wait, here relay. Got relay? No, no relay. Hey, got relay switch on here. Now, so this is an automatic switch. Okay, the aircon will be switched on automatically when room temperature is more than 28. Wow, so good. Yeah, actually nowadays, yeah, the the good aircon they have the thermistor inside to adjust it always like on on 28 degrees Celsius. It's okay. We want to save energy. Normally we manual lah. Okay. Now here got one circuit, then here got another circuit. So relay switch is used to got asking or not? Okay. Use small voltage circuit to switch on high. Okay, that greater. Okay, forget my English. Okay, high voltage circuit for safe lah. Yeah, so circuit 1, circuit 2. Circuit 1 to control the switch for transistor. Then circuit 2. So relay switch is like this. A current here will become electromagnet and switch it, close it, and the current flows here. Okay, so this is the thermistor. Thermistor should be thermistor. This is BM, but it's okay lah. Okay, so now here, VB always at the bottom, base voltage always at the bottom. What type of transistor is it? Right? What type of transistor is it? NPN. Thank you very much. Yeah, so it's PN. This is direction of current. Current always from positive to negative, and transistor is like a sandwich, NPN, correct. Yeah, you may ask teacher, NPN, NPN can, all can, no problem. Okay, so now the resistance of thermistor when surrounding temperature is 50 degrees Celsius is 3 kilo ohm. Wow. 50 degrees Celsius is in Africa already. Negative NPN. Thank you. In Africa already. Really? Okay, based on diagram 4, calculate the base voltage VB. So thermistor 50. So it will become 3K ohm. 3K ohm. Okay, so now 3K ohm. So what is VB? It doesn't mention voltage. It's like this. This one can, yeah, this is different from the question in 2023. Because this one they use potential divider. Yeah, if you did the 2023 topical from the trial, they would mention voltage here, but this is not. So you need to do the ratio lah, proportional and ratio problem lah. So it's like, I fast lah, just quick review lah. Okay, so let's say I have 300 sweets. Now I want to separate it into 2 packets, the big pack and the small pack. Okay, so now the ratio in between would be 6 to 3. How many you will get into this pack? I believe you will do So the total ratio here actually is 9. 2 parts, 9 portion. Okay, so it will be totally 9. This big pack gets 6 portion times 300. So you will get the 339三一三三三九三一三三二六 so you get 200 sweets. Then this one is total 9 portion times 300, but this one only get 3 portion. So 31339 you will get 100 sweets. That's the proportion, ratio and proportion. So same thing now. 9 votes is divided into 2 parts. How many portion? 3K and 15K. If you want, you can ignore the K lah. So it's actually the ratio and proportion is 15 to 3. Okay, so total we get how many? 18 portion. Now what they want VP. VP got how many portion? 15 times total how much? 9 votes. So 9199218. So we will get 7.5 votes. This one called potential divider. Potential divider. Looks weird, looks strange, but actually it's your Form 1 maths. Rates, ratio, and proportion. 9 votes is divided by 3 portion and 15 portion. Total 18 portion. Then this one 15 portion. 15 over 18 times 9. It's your Form 1 maths. Okay, so VP will be 18 15 times 9 volts. So 91992. So answer 7.5 volts. Then the current flows through the thermistor. Balani. Okay, so it's like this actually. So since here is 7.5 volts, this is 9, this is 7.5. So what we get here? We will get 1.5 volts here. Thermistor 3K. So we use, because this is direct current, please use V equals to IR. So V is 1.5, R is 3K. So now we get V equals to IR. V is 1.5, I 3K. 3K, 3,000, 3,000. So now I will equals to 1.5 divided by 3,000. So I equals to 1.5除3000. So it's 5 times 10 powers of negative 4 ampere. That's it. Yeah, so potential divider means 9 volts will be divided into 2 parts. This one more resistance, more voltage. Less resistance, less voltage. Okay. Because this is a series circuit. Series circuit. Okay, so now shows the graph obtained from activity relationship between IB and IC lah. Okay, sure, they ask magnification factor. Calculate the gradient of the graph. Okay lah. Gradient will be change dy over dx lah. So it will be 62 minus 0 divided by 0.4 minus 0. So answer 155. What's the unit? What's the unit? What unit? Unit very easy lah. You just take y-axis unit milliampere. X-axis milliampere. Cancel. Yeah, no unit. Done. Yes, very good, Daniel. Yeah, no unit. Yeah. So every time when you want to find unit, whatever unit here, you put here. Whatever unit for X, you put down. See, they can cancel or they can combine. So for example, if I have a unit Pascal and unit T, Kelvin. Tell me, what is the unit for this gradient? I just want unit. So y-axis Pascal, x-axis Kelvin, right? Join them. PA per Kelvin. Yeah, PA per Kelvin. Yeah, that's it. Oh, that's very easy to find unit for gradient. If they ask gradient, remember, also need to find unit. Just take here, divide, and you combine. Very easy for you. All right, so now next, what is a physical quantity represented by the gradient of the graph? Physical quantity. So if you have no idea, read back the formula. Now here, beta equals to IC divided by IE. What's beta? Good question. I also forgot. I think it's magnification factor. Here. So ngam. So ngam. Current amplifier. Amplification factor. How to zoom in. Here. Amplification factor. So like it's amplification factor. You may feel it's you learned before. Yeah, correct. Congratulations. You learned linear magnification before. That's for lens. Magnified, larger. But this one we call it as amplification. Okay, amplification. Okay, so now state another function of transistor beside being used as automatic switch. How? Yeah, so we can say it's a current amplifier. Current amplifier. Why? Because see, zero, this is small voltage. Small current can enlarge, can amplify to big current. Okay, also, so automatic switch of current amplifier. Okay, so now the same thing lah. So can they say okay, the potential difference of LDR is 1.2. Oh, this one like it easy lah. If this is 1.2 means here will be 7.8 lah. Because 9 volt is divided into two parts. Okay, so transistor, this transistor is automatic switch. Must have automatic, automatic switch. Then calculate the resistance of LDR. Okay, for this, easier, since voltage is given, right? Again, use ratio and proportional method. 7.8 volts is 10 k ohm. So 1.2 volts, how many k ohm? So we proportional method, this times this, divided by 7.8, 7 by 7.8. Yeah, so we will get 1538.462 kilo ohm. I mean ohm. 1538.462 ohm, or you can say 1.538461 kilo ohm. Make sure you write all of the decimals, especially for gravity. Okay, so like this only lah. Okay, like this only. So what is this? This is here IC divided by IB. IC divided by IB. So IC divided by IB. So beta equals to IC divided by IB. Right? Everyone tell me 5 MA divided by 50 microampere. How much? Ah, oh no. 哎，刚刚是谁呀？哎，刚刚是谁呀？Okay, answer would be 100. Why? Actually, this is 5 milli times 10 powers of negative 3 divided by 50 times 10 powers of negative 6. So, should be 100 lah. This one is in my YouTube shorts. You can go see. I shows I show how to find prefix by using two calculator. You just type Jegusa. Go see how to press prefix. Jegusa shorts. Inside when you see calculator, you check which one you use. Okay, so now this one is done already. This one also we done before. Okay, so now this is the wave. This wave is from here to here, from region A to region B. This is our trial paper. Right, so we just look at region A, lambda A, region B, lambda B. Okay, okay, so which one deep, which one shallow? So this is deep, this is shallow. Because when you put perspect sheets, it will be net shallow. So deep will go faster. So lambda greater. Shallow, speed slower, the lambda also smaller. Okay, name the wave phenomenon. So this is refraction. Then draw a normal line. So this is boundary. Draw a normal line here. Normal. You don't write also, never mind. You don't write. Don't label, never mind. So like this, okay? Hence draw the direction. So observe A and B. Compare the wavelength. This one I will try. Okay. By the way, depth of water and wavelength. Deeper the water, larger the wavelength. Wavelength and speed. V equals to F lambda. So speed larger, lambda larger. Okay. This one V equals to F lambda, our trial. Okay. Now this one is the orbital period T of the satellite can be determined by Kepler's third law. As long as you see two objects surrounding one planet, for example, Earth. So sure is Kepler's third law. So where is Kepler's third law? Find formula. Formula is here. Formula, Kepler's third law. So actually, you just need to translate it into the original equation. You learn this in maths. So we say T T R R square cube 1122. So actually, what is this? This is saying T square over R cube equals to a constant. So T square equals to K R cube. So T square directly proportional to R cube. Translate this enough. So Kepler's third law, we say it as we always start the definition with it as the square of period is directly proportional to the cube of orbital radius. Means the distance from center of satellite to the center of Earth. Center of satellite to the center of Earth. This is R, RP, RQ. So actually most of the definition is not saying all, but half can get translation from formula. That's it. Okay, so now based on diagram 6, compare the orbital radius of P and Q. This one very obvious, orbital period. Okay, this one for number 5 and 6, since one question only, you can directly say PQ, radius of P smaller than Q. Can. You use this symbol, can or not? Can. But only for 5 and 6, 11 don't use, Okay, so linear speed of P and Q. I just directly see here. So linear speed P bigger than Q. Period of the man-made satellite PQ. PQ, period. Oh, they don't say that. How? Oh yeah, they don't say period. Oh. It's okay, we can see from here. Radius increase means period increase. So radius increase, Q increase means the period would be more than P. Okay. But most of the time they will give 3. Then just linear speed and orbital period. So if you can find formula here, yeah, this one. V equals to Gm over R. E equals to Gm over R. Okay, so we will say orbital radius increases, speed decreases. So increase, decrease. Orbital period and orbital radius. So this one we use T square directly proportional to Q. So this increase, this increase. We can double check. This one double check. First one is you can see linear speed and orbital radius. Orbital radius and speed. Bigger, smaller, increase, decrease. Then second, orbital period and orbital radius. Orbital period and orbital radius. Same, right? Same, right? Increase, increase. So this is how we do double check. All right. Okay, so now next. This one is the height of satellite P and Q from the surface is this and this. Orbital period for satellite Q is 24 hours. Calculate the orbital period of satellite. Oh, by the way, the English part, they forgot to give. Radius of the Earth is 6370 km. So what we should do, so we say 1 is P, 2 is Q lah. So P and Q from the surface is this, the height. So actually it is 2 and 3.6. Now, so actually this is 2 times 10 powers of 4 km. And this is 3.6 times 10 powers of 4 km. Be careful, because this R must count from the center. This height, this one many people wrong, because the height means from here to surface only, from here to surface only. So don't forget to add radius of Earth. Don't forget to add radius for Earth. Understand? Don't forget to add radius of Earth. Radius of Earth. Okay, so now we say T, TP, TQ, RP, RQ, square Q, square Q. My style, I feel I write same category is easier. I write all the same category things first. Okay, so now TP, don't know. TQ is 24 hours squared. Okay, then orbital period of satellite P. So now TP squared. So RP will be 2 times 10 powers of 4 km plus 3670 km. Km means times 10 powers of 3. Then this one is, forgot Q. This one is 3.6 times 10 powers of 4 km plus 3670 times 10 powers of 3 Q. That's the difficult part. That's the confusing part. You must plus first times km, then only you Q. Okay, so I think now you know what to do, right? So it's Tp squared equals to 24 hours squared times 2 times 10 powers of 4 plus 2. Sorry. A bit tired. Times 10 powers of 3 cube. So if you want to get t, remember this t will be square root lah. Is square root lah. So you will get the answer lah. Answer is attached in the WhatsApp lah. So the tricky part is remember to add the radius. The tricky part. Because they say what? What they say from the surface. So don't forget to add the radius. The tricky part is this only lah. Quite easy. Just calculation seems complicated. Yeah, but let's say if you substitute everything, you get 1 mark already. Okay, so like that only lah. Then chapter 7. Chapter 7, the tricky part is EV, applied to EV. Okay, it's like this. 1 EV equals to joules. 1 EV equals to 1.6 times 10 powers of negative 19 joules. 1 EV equals to 1.6 times 10 powers of negative 19 joules. But if like this, the answer is 0.0000000000019. Okay, 16. So it's something a little bit hard to recognize lah. So because this is energy for electron atom, the subatomic particles, that's why what we do, yeah, so we convert that to 1.06. So if you want to change EV back to joule, I just times this enough. 1.6 times 10 powers of negative 19. Actually, same as the charge of electron. Okay, so for example, this times 1.6 times 10 powers of negative 19 joules. Something like this. So here would be the threshold frequency. How to determine the threshold frequency from the graph? How? They didn't ask you how much. They just say how. So actually here you cannot get that because formula is E equals to W naught plus KE max. So the formula is HF equals to HF naught plus half MV squared. So now we only get KE max. If we want to know threshold frequency, we should get the photon energy. then only we get the work function and threshold frequency. So we say W naught equals to HF naught. But unfortunately, we don't have this. We don't have work function, we don't have photon energy here, so we cannot direct get. So actually, we read properly how to determine threshold frequency from the graph, So you no need tell how much, you just say threshold frequency is the x-intercept of the graph. Is the x-intercept from the graph. That's all. Okay. Then if we extrapolate it, actually you will get two numbers here. So this one will be work function for A, work function for B lah. So you will see everything is here already. KE max is here, work function is here. Then we can find the photon. So now, teacher, since x-axis is actually frequency, do I say F-intercept? Okay. You want to say F-intercept, okay? X-axis, no lah, I think x-intercept lah. Because x-intercept means the part that graph intercept on x-axis. Better say x-intercept. Okay, so now compare the threshold frequency, even though they don't show anything, but I think all of you very good in graph already. So let's say this is 1, 2, 3. Of course, that B more than A lah, okay? Threshold frequency of P and Q. Q more than P. Of course, if you want to say FOA smaller than FOB, can or not can? For number 6, number 11, please try full sentence, number 11. All right, now compare the maximum kinetic energy since they're given here. Yeah, so it's P larger than Q. Compare the gradient of the graph. Lie fast. Compare the gradient of the graph. Yeah, the same. So P equals to Q. Because the gradient of the graph actually is Planck constant. Amen. Relate the threshold frequency for a metal of maximum kinetic energy. So use back this formula, E equals to W naught plus KE max. So actually KE max threshold frequency is under here. So we say so E equals to this plus KE max. So E equals to HF naught. F naught is threshold frequency plus KE max. So E minus HF naught equals to KE max. So now from here, can you please tell? Can you please tell if threshold frequency increase, what happened to KE max? Yeah, decrease. So for example, E is 10. So like case one, 10 minus HF. Let's say H is 3 lah. Okay. And in the beginning, F naught is 1. So now KE max will equals to 10减3 7 7 joule. Then case 2. E is 10, E is 10, minus, let's say H is 3. F naught increases, become 5. So now, sorry, cannot, too much. 3, 1 become 3, so F naught increase. So 10 minus 9, we will get 1 joules. So yes, increase the frequency. So relates threshold frequency with maximum kinetic energy. So threshold frequency increase, maximum kinetic energy decreases. Okay, work function and threshold frequency of a metal can be related by the formula W equals to HF naught. So state the relationship between threshold frequency and work function. So increase of relationship. That's it. Teacher, will the value of EV be given? Should be given. Should be given. If not given, you just remember. No need remember. Your calculator can get 1 EV. Where is the constant? Shift constant. Charge. The charge. Planck constant also you can find from your calculator. Now, atomic mass constant also you can find from your calculator, but it's given now. Charge of electron. Actually, it's the same as your charge of electron. Where is it? Charge of electron. 23. 23. 23. 23. Here. 23 is in your calculator. 23 charge of electron. How to find here? 23 charge of electron. Hắn lớn ơi. Thank you. Chàng EV tiền liệu ở chàng 6 universal 在哪里？我还是看不到。妹妹，谢谢你。Number 3. Yeah, I got it. One constant universal 不是 constant electromagnetic. Here. We'll find one constant, shift constant. Okay, one shift constant is 7. Constant is 7. You'll get this universal electromagnetic. You choose electromagnetic number 2. Then you will get the E here. Number 3. E number 3. But most of the time they will give one. If they don't give this, you just say if they say need to be in SI unit, you say 1 EV equals to 10. 1 EV equals to 1 joule. Can, if they don't give, they should give because it's a constant, they should give. Let 1 EV equals to 10 joules. Then you sub inside. You change to this. So do not worry. Anything you find it's wrong, you must try to answer lah. Okay, understand? You must answer. It's a must to answer. Be careful about this. 388 no, this is a prefix times 10 powers of negative 9. Don't need memorize. Also can find in your calculator. Okay. Okay, what happened to the kinetic energy if intensity of light shines on this increase? Okay, kinetic energy only related to E equals to W naught plus KE max. So this is HF equals to HF over HF lambda. Only frequency of light and threshold frequency of metal affects kinetic energy. Light does not affect at all. So no change. Then intensity of light affects what? Affects the intensity of light means how many beam of light. So let's say this is the light. E, 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 E. The E light will go up. 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 So this is strong intensity. Then this is weak intensity of light. So one light, one electron go up. So this is called high intensity of light, 就是光的亮度。If many light, many electron up So one light, low intensity, one light, one electron up. So actually, intensity of light affects what? Affects the numbers of electron emitted. 可以吗？ Okay, so now this is principle of conservation of momentum, and then they stick together. So formula is MV M1U1 plus M2U2 equals to, this one should be M1V1 plus M2V2. But because they stick together means V is the same. So we factorize out M1 plus M2V. Okay. So since this one is, if this is stop at rest Y at rest, so we no need worry because the U is positive, positive. Then go here will be positive, positive. But if this one is not at rest, okay, not at rest, so what happened? Negative, negative, negative speed. Okay, then what is meant by principle of conservation of momentum? First, plus means total. So we say MV is momentum. So total momentum before collision will be equals to total momentum after collision. So before same as after. Can I use equal sign? Can mathematics sign can be used. Total means plus. Got two objects. So you got two momentum. This one you compare yourself. Then this one, determine the mass of trolley X if total momentum after is this. After collision, so we use m1u1 plus m2u2 equals to total momentum is 8. Like this enough. Why? They already say lah. 8 lah. So we see back lah. M1 okay. This is something a little bit strange lah. Normally we don't do. So this is 3 mass 3m, mass 1m. It's like ratio and proportion lah. So total would be 4 lah. But we say m1 would be 3m, gu is 4. This is stationary, so this is 1m times u0, so it doesn't matter. So we put like this. M1 is 3m times 4, positive 4, plus M2 is 1m, but U2 is 0. So it will become 0. So it will say 12m equals to 8. M equals to 8 divided by 12. M equals to 7. 0.667 kg. Is this the answer? No, because mass of X would be 3m. So 3 times 0.667. Answer is 2 kg. Okay. So be careful about this lah. This is a little bit tricky because it doesn't give you directly. This is indirect. So we say tricky lah. Once you find M, you must remember times back the 3 lah. A tricky question. What will happen to the common velocity if trolley X of bigger S is used in this collision? M1u1 plus M2u2 equals to M1 plus M2v. So means if M increases, so now this is 3 kg 4. So 3, 4, 12 equals to original is 3.667 feet. So original V equals to 12 divided by 3.667. V will equals to 3.272524 meter per second. Now, if increase, let's say mass becomes 6, so the speed the same. So 6.667 feet. So V equals to 24 divided by 6.667. So it will become 3.5998 meter per second. Yeah, so answer is increases. Yeah, so encourage you all, if you have no idea what happened, just use original, compare with you, increase the mass. If you got time now. Okay. So if you really don't know what happened, just calculate it up, give it some number from 3 to 6 increase. Okay. Okay, yeah. Oh, okay. Oh, okay. 147 EV. Oh, sorry. I didn't read the message just now. Okay, last question. Right, so this one, KFC and Vroom, vroom, rim, rims, ri, ri. What type of mirror is it? Concave or convex? It's concave. Okay, concave mirror. Okay, concave mirror. Okay, based on diagram 7.1, state one characteristic of image. Yeah, concave mirror because U smaller than F. Yeah, so volume one, you say virtual enough, or you want to say virtual enough, or upright or magnified, or just see from here. If you are not sure, whatever, you see larger magnified, and some more, the eye on top, the image eye also on top, upright. So normally if upright, sure virtual. Up to you. These three, which one you want to write? Draw the ray diagram, KFC. And for concave mirror, please draw first concave mirror, concave, because we see from here. So concave mirror. So now KF0, K. Use which F? How use which F? The F in front of mirror or the F behind the mirror? Oh, I forgot how. Cave 就是它凹进去，你看。Yeah, heels in front. Why? Because see, look at the curvature. It's a circle in front. So please use these two in front. So if this is a convex, let's say that. So if let's say this is a convex mirror, use the F and C behind. So yeah, look at the curvature. So you must know is concave or convex first. So object is here, our eye is here. So yeah, so since this is a concave mirror, let's draw complete the circle. So the circle is in front. We use F and C in front. Yeah, thank you. Yes. So yeah, so we use KFC, KFC. FKC also can K F must pass through F, use ruler. Tomorrow please bring ruler. C. Then we these two diverging, so we extrapolate it. Extrapolate it. We come here. This is the image. This is the object, and this is the image. Must shows image, must show image, draw image. By the way, this image is virtual or real? This image is virtual or real? Yeah, virtual. Okay, remember I showed you before real image and virtual image. If you want to magnify real image, magnify virtual image. So this one you should choose longer focal length. This one you should choose shorter focal length. Here. Here. Now you can see lah. No matter. So this is virtual image. Why? Virtual always upright. Okay. So if you want to make it larger, we see now this is F1, HI1. Now if I do this, I was shorten the focal length. Then I'll increase the height. Get the idea? If virtual is shorter. So virtual is not real. Not real means the size and the focal length is inversely proportional. Okay. But if it is real, I can see real image. Real image. Now, real image is first, this is F1. This size, HI1. Then this one is, sorry. My fault. Now I increase the focal length. Can you see I increase the focal length, then I increase the size of image. So for real image, F and height directly proportional. Increase the frequency, increase the height. Okay. This one I mentioned before. So if you want virtual image, terbalik. If you want higher, greater size of image, lower focal length. But this one is for anti-tap mirror. Thief mirror is convex mirror. Diameter should be big lah. So should be R. Why convex mirror? Because here. By the way, if you want, you just type fake geometric optics. Fake geometric optics. Yeah, here, geometric optics. Then you can directly play here, or you want to download here also can. You can download it, or you can directly play here. Got lens and got mirror. Lens got convex, concave. Mirror got concave, convex, and plane. Plane is learned from one already. So now this is the convex mirror. Now see, no matter how it always convex mirror always foot upright. Upright means virtual. Always diminish. See, no matter how, always diminish. Okay, so diminish means what? Means we can see wider. Diminished image means wider field of view. Okay, wider field of view. Wider field of view. So it's like, let me see, convex mirror. Now, like the car side mirror. Now, this one, the roadside mirror in the shop. Wow, this small mirror can see the whole shop. Okay, so we say diminished image means wider field of view lah. If you want, I think no lah, cannot bring the spoon. See, you can see my whole house. Got 2 fan, got computer. Okay, why you can see that? Because all of the image diminish. So we can see wider field of view. This is convex mirror. This is concave mirror. You can see it's magnified and upright. Then terbalik. Because it's very close distance, very far distance. Okay, so the diameter of the curved mirror should be big lah. Why? Because mirror can reflect more light. Mirror reflection, you all. One more hint is always check you are answering mirror question or answering lens question. Understand? Lens is refracts more light. Mirror reflects 反射，这是折射 refracts more light and reflects more light. Okay. Always check. Like me also, until now also I confused. I need to check question by question. Am I answering mirror or answering lens question? Okay, so this one also we learn in trouser. Okay, last. Okay, so for this chapter only got 2 things. One is Fleming's left hand rules. One is Fleming right hand rules. So left hand rules is motor, produce force. Right hand rules is generator, produce induced current. Okay, so for motor, we are using catapult field. For induced current, we are saying electromagnetic induction. Okay. So this one produce force, so it moves. Got force, got motion. This one is current, so they cut magnetic flux, so got current. Okay. Okay lah, so catapult field, same thing lah. Okay, the rest is almost the same thing lah. You all try to do lah. Okay. Now you just drill as many questions as possible. Then anything not sure, just check back the concept. I'm free at 9. You all can WhatsApp me lah. I try to help you lah. Try my best to help you in last minute lah. And then I hope you all can sleep as usual lah. Sleep as usual. Yes. Treat it normal lah, treat it like trial only lah. Actually, SPM, it's okay lah. SPM, not so hard lah. Somehow physics, I feel physics is the easiest among chemistry and bio because got many common sense things okay. Can sure cannot sleep. Sleep lah, go sleep lah. Just maximum 11 o'clock go sleep. Okay. Okay, because you physics teacher, correct lah. Up to you lah, up to you lah. If you want to like, I also know cannot say you all lah because last time also I scared chemistry, a lot of things to memorize. So I like overnight lah, like just slept 2 hours like that, then go to take exam. But one of the problem is what? One of the problem is I find out, the brain like not function properly lah because sleep 2 hours only. For me lah. So I don't encourage you to overnight lah, ha. Okay, need to revise meaning agak-agak can already lah. Yeah, go revise. Anything I still can help tonight? Tomorrow I'll go invigilate in other school. Okay, so see how lah. I don't think physics very hard lah. Okay, so that's all for today, and this is our last class. Okay, thank you everyone. Bye bye.
Thank you, teacher.
Welcome. Bye bye. Bye 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 Kayang. Bye Adele. Bye Daniel. Bye Xavier. Bye Joshua. Yeah, miss you too. Bye Nana. I'm not sure who are you. Bye bye. Bye Hanlon. Bye bye Jia En. Bye bye Ellen. Bye bye.